Welcome to you all. Thanks for the ones who organized this meeting in such short notice to actually make it happen. I think it's a good thing for the community, and it's good to see that there's so much people interested in what is happening in the OpenEdge community and in progress in general. Today I'm going to do a presentation on OpenEdge and Docker. It's a bit of a 101, although at some point you may find that it's actually going quite fast as well, because there's a lot of grounds to cover. My name is Bronco Oostermeyers. If you look at the website, you actually see that they think my name is Bronco Oostermeyers with an S, but I think one is enough. So I work with OpenEdge since 1969, 25 years, and well, considering the company around here, I almost feel like a newbie. I mean, but 25 years, worked for various companies, among which a Dutch company called Walvis. I worked for Unit 4, worked for Progress Services, and nowadays I work a lot with Docker, Kubernetes. Acquainted myself with the Go language recently because of Docker and Kubernetes. Do some identity access management with Keycloak. And I used to do some client-side programming as well, but I try to stay away from that as much as possible. The server-side's a little bit more interesting as far as I'm concerned. Since 2014, I work for a Dutch company called Flusso. You probably all know, and as such, I'm here. So that was who I am. Who are we? Flusso, Dutch consultancy firm with OpenEdge, the biggest one actually. We do a lot of progress technologies as well as open source with Java, native script. We develop web apps, and there are some technologies we rather not talk about in these conferences, but I'll just leave it at that. Okay, on the topic, what is Docker? Docker is a solution for developing, sharing and running applications. So there's all sorts of, in every aspect of your life cycle of your application, there's a solution for Docker somewhere. And that may not be the case once you start with Docker, but once you get a certain level of maturity, you can see Docker everywhere. Docker does so by running containers. And nowadays Docker is pretty much the same as containers, but it actually is not. It's a little bit like aspirin. Aspirin is just a medicine, which is a brand name, and Docker is a brand name as well. But it's just, Docker is doing containers, and there are other solutions for containers as well. But for sake of simplicity, I just call it Docker because it sounds nice. Now, what is Docker? I already mentioned it's used in containers, and the way I look at Docker is just it's a different version of virtualization. It's a different view on virtualization. On the left-hand side, we see the traditional virtual machine setup, where we have a big piece of metal with a hypervisor on it, maybe an operating system, but most of the time just the hypervisor, and we run the virtual machines on top of that hypervisor. But we run complete operating systems along with every application software you need. So in this case you see 3 virtual machines, and so in this case you also see 3 entire virtual operating systems. They're probably Linux, but there is a certain drawback to that setup, because if you run 3 operating systems, you have to maintain 3 operating systems, which can be costly and which can be the source of some what you do in maintenance on the first one may not be the same as what you do on the second one. So you try to have a lot of variations in what your landscape looks like. The other thing is that every operating system consumes resources. It consumes CPU, it consumes memory, and it consumes disk space, and all those things are pretty much the same across the board. I mean, if you run 3 times Linux, you have 3 operating systems basically sharing the same files and everything. But you can't share them. So from a resource point of view, there's quite some overhead in running 3 operating systems next to each other. And now if we shift to the right side, which is basically the container part, you see that a different setup is being taken. I mean, right here we have just one operating system, and Docker runs on top of that operating system. So you typically have the host operating system, what we call here is Linux. and on top of that we will run Docker, and we have all the applications running on top of that without the overhead of the operating system. Almost all the overhead, because there are some operating system stuff in Docker containers as well, but it's relatively minor considered when you're looking at the left side. Now, if there's no operating system in Docker containers, how do you run this? Well, that's where the Docker part here is kicking in, because Docker actually provides some sort of abstraction between the underlying host system and the application you run on it. So whenever app A, in this case, wants something of a file system, it runs the API via Docker to the host operating system to make things happen. Now, because you only need one host operating system, your maintenance goes down quite considerably. Even more so, this sheet actually shows what this is when you run it on your own hardware. But if you look at it from a cloud perspective, if you run these kind of things on Google Cloud or on AWS or on Azure, you don't even have to care about the host operating system at all, because that was the cloud provider for doing it for you. So you only have to focus on what you do within your containers. So the host operating can, by the way, be Windows just as well. We run Docker on Windows Server 19. You can run Docker, and on Windows 10 or Windows 11 you can run Docker just as well. And it's actually pretty good. When I first made this presentation, it was a little bit, well, not everything worked, and that had to do because the Docker layer was not implementing all the APIs. So there were some calls which you make from the containers on the top side to the host operating system, which actually didn't work. Nowadays, I think it's better. So we talk Docker, but what are these containers? Well, a container, you should look at a container which is actually it contains stuff. It contains ideally it contains the entirety of your application, or a part of your application. And the reason why that's interesting, because if you put everything in a container, you can move the container, we'll talk about it later, but you can move the container from one computer to the other one and it runs exactly the same. And that's what these strong points are. We all run into, when testing software, it's like, oh well, it runs on my computer. Yeah, because the setup is not entirely the same as it is on the other one's computer. And with Docker you solve that, because whatever is in the container is just in the container. So the container runs pretty much the same everywhere. And you can share these containers as well. They run the same, but if you look at it, what is in the container stays in the container. We'll get back to that later, but that implies that once you shut down the container, everything is gone. And that's something, yeah, you should, there are ways around it, but you should realize that once a container is gone, everything is gone. So be prepared. So if you run a database in a container, you shut down the container, well, you can see where I'm going. These containers are runtime components, and containers are based on images, and conceptually you could say that a container is an object, whereas an image is a class. That's pretty much the way how they relate to each other. So now, if you start programming normally and you start programming a class, you're writing code and then you make up the class and you instantiate and then you have an object. And in the Docker world, it's pretty much the same. Docker images are built via so-called Dockerfiles, and which you can consider the recipe for your image. The images contain basically everything, but you know, they are not singular. I mean, you can start with one container and build the next container on top of it, which basically is what OpenEdge is doing. For example, if you download the OpenEdge PaaS containers, which there are, you can build your own application on top of that. So you start with whatever Progress delivers, and you start working your way. You have your Docker file, and whatever your application is, you put that on top of it. So you can utilize whatever Progress already did for you, which is quite powerful. Well, all the various steps you put in a Docker file are called layers. they end up being a layer. And why these are handy, we'll see that later. These images are basically what you're going to share. So if I create an image of my application, I can put it in a registry. First I build them locally, then I can put them in a central registry, and then, for example, you can download the same image from the registry, run it on your computer, and it runs exactly the same as I do. We'll see more about that later. One of the registries is Docker Hub. Your cloud provider has Docker registries. You can build Docker registries on your Synology NAS, or you can run your own Docker container to provide a Docker container, Docker registry. Okay, Dockerfile. Like I already said, you build on top of what others already did for you. You never start from scratch. Sometimes you start up with an operating system at the from level, because the from defines what you are starting with. And now I said you don't need an operating system, but you do need some tools like VI or grep or whatever. And that's if you specify a host operating system with a from, no sorry, not a host. If you at the from page you specify an operating system, you get the tools like VI, grep, also, etc. It's almost always Linux. Windows containers are possible, but I wouldn't recommend it because at least in the OpenEdge world they are not supported anyway. So for this talk we just focus on Linux containers. Now in the modern OpenEdge versions you need to supply your own Java, for example. If you install OpenEdge 12.1 or 12.2, it's all nice, but the first thing is to ask, where is your Java setup? I said you could utilize previous images, so what I do here at the first line is I say, okay, I have a CentOS operating system, but there's already the OpenJDK on it, so I don't have to install the OpenJDK, it's already there. It's just one line and then I got everything covered. I just need to know what the location is, but that's a different story. What we're trying to do here is install OpenEdge, just the basic pattern. We all installed OpenEdge, most of us on Linux, maybe not. But what we're doing here at the add line is that we actually copy the tar or the zip file to an installation directory. We copy the ini file, which is basically the recipe for what we're trying to install. We already set it up. And then we do run install, just we would like it would be done on Linux. So the only difference here is that we have the add, the copy, and the run. Those are the instructions for Docker what to do with these statements. The runs you are actually executing. The adds are just the add step. In this case, for example, copies the contents of whatever is in the tar file and unzips it in the install OpenEdge directory. So. And over here at the run statement, the second run statement, I remove the license file because whatever is in your container stays in your container unless you remove it. And even then it's still there, but I will get to that later. But if you are deploying images with your CFG file in it and everybody else sees that, gets that image, then they have your license. And well, with a Progress developer's license may not matter because they are only valid for a year. But if we have a perpetual license, I don't know. So what we are saying to Progress, okay, what we do later on, we install the license at the /app/license Progress file. Progress CFG environment file tells Progress, you should look up your license over there. And to the volume, I get to it later. But if we build this file, because once you have a Docker file, you need to start it turning into an image, and that's actually what's called building. Well, I already mentioned, every line in your Docker file is a layer, and these layers are at the right bottom you see what actually is there. So if you have a layer, it turns the layer into a hash, and with that hash I can say if you change the layer, the hash changes, so it sees that it needs to rebuild it. But Docker is quite smart. If you have a Docker file of 10 lines, and you need to build it. It can be quite a lengthy process. But Docker notices if you didn't change anything on the first 8 lines, it just skips them because it already got all those layers built. And basically what an image is layers on top of each other. Now, what is in the layer is retrievable. So I already mentioned that if you install OpenEdge, in one layer there's your progress CFG file, so it's retrievable, even if you remove it. That's because there's still some layer which already got it. Now, I here show the command in which you can show all the layers which are actually in the container, in the image, which can be handy because sometimes you get something from somebody and you don't actually know what they did. For example, if you take the progress image, you want to know what did they do to create this image, because it's useful for you later when you start to build your own images. Now, to mitigate the license file issue, we have a thing called multi-stage build, and that sounds a little bit exciting or scary or whatever, but it actually is 2 Docker files in one. And over here you see the top part, and for the viewers at home I'm just going to show a little bit with the cursor. In the top file over here you do the same install we already saw, but we say here in red that we call this install. So we have 2 Docker files in one. One is called the install Docker file, and the other thing is the instance Docker file. Now, as soon as you hit the second from statement, you throw everything away except what is on the file system and you copy it. So we throw everything away which we did in step 1, and then we say, okay, from the install part we copy just user DLC and user WRK, the work directory. And now all the other layers are gone. So now there's no longer the progress CFG file somewhere hidden in your image, and that's a good thing, because if you are smart you can extract these files anyway. So, and then your license is still out there, and well, the progress account manager probably cares if you throw away your licenses out on the streets. So normally your Docker file is just on your file system. You start working on it, Visual Studio Code. All the other files are necessary for creating the image. I got a build script, I got the response INI, I have a start file which defines what actually happens if you start a container. Now, all these files, you run the build from this directory, and all these files are called the context. So basically what's happening when you're building an image, that all these files are loaded into the context. And together with the Docker file, you run the build. Now, what happens if one of these files changes, the context changes, and then Docker knows when you rerun a build that, oh, well, my context changed, so I needed to do everything again. If the context doesn't change, and your Docker file didn't change, and you run a build, you're done pretty fast, because it knows that my context is the same, and all my layers are the same, so I'm done in 2 seconds. Although, when you see over here, the progress file is quite big. So if you're trying to build your context, it has to draw in around 700 megabytes. And nowadays it's better than it used to be, because at 11.7 there's Java in it as well. So the zip file for OpenEdge was around 1.2 gigabytes, which is actually a lot. Containers are supposed to be small, but it's kind of hard. And small, we're talking about 100 megabytes, but in the progress world it's impossible. Now, at the bottom there's the statement, and the -t says the image name, and the image name is basically 2 parts. You have the name, that's the one before the semicolon, and you got a version. So in this case, I check my install as 12.2.6, and you can imagine that you can do a 12.2.5 as well, and 12.2.4. So it's quite easy this way to, if you add your application to it, and you want to test your software, that you don't have to install every progress software, progress version on your local system. No, you just run the, you take another image and you download the image and then run that one. So it's getting much easier to actually run various versions. If you omit the version part, it's called latest. So then, and if you try to reload an image and you don't specify a version, then it's taking whatever is latest. This is what you see when you run, well, at least on my laptop, Docker images command on the CLI. And I do a grep with OpenEdge because I have a lot of images on my laptop. And this is basically what I got. But what we just built was the OpenEdge PAS dev image for the version 12.2.6, which contains just the installation for PAS. Because the next thing is, now I just have an OpenEdge installation with nothing on it. But the next step is to actually create a PAS instance. The reason why I think this is a good idea, because if you try not to do everything in one step, you can really utilize these things much easier. So the next thing is over here, I'm going to create an instance, just no application specifics in there. So we see the passman create statement. I run them on port, the standard ports 8810, 8811. I give this instance a name called ASPAS, and I specify in which directory in the container I install create the passman instances. Well, the next step is just to turn down the transports I don't use, and since, well, Mike calls them the best thing since sliced bread, since there is such a thing as a web protocol, web transport, I never use the other ones as well. APSV is questionable because if you have a 4GL UI, you still need the APSV, but for the rest of the world, if you have Angular clients and so, they all communicate via the web protocol, and I would suggest that especially REST, forget about it. It's cumbersome and don't do it. Last statement over here is what I already told you. What is in the container, it stays in the container, but it's not entirely true unless you specify so. And what I do here is I say to Docker, everything runs inside except, but you can access the port 8810 and 8811 because, and it's an explicit step, because if you don't specify this, you can't access your instance. So now, next step, we build this one. As you already mentioned, the from is what we did at the first step. We build this one and we call this OpenEdge PAS instance. As you see, there is no application logic in this at all. So you can, but you do have an instance. So creating an instance takes time. So for the next step, maybe you have 2, 3, or 4 different PAS instances running, but you can all utilize this image to create that specific the next image for your application. So the next step is, from your image, which we just created, we're now going to go into some application logic. Some step I created, my application is in a PL file, and the PL file BFV are my initials, so there's BFV everywhere. I add that to the PAS directory and the OpenEdge directory, and over here, what I do, I use the oeprop command to set the values in the OpenEdge property file, just as you normally would do with your text editor. Right now you're trying to script everything. Scripting is good, scripting is repeatable, and when creating images, you basically don't have an option. The next run command though actually tells that I have a web handler in the PL file added here. There's a web handler called bfv libpass.webhandlerxt, and I mapped that as /. So whenever I hit the PAS instance with /, or /web actually, because it's a web handler, then whatever is in the web handler ext class is getting kicked off. Last command is the CMD file tells you what do you want to do when you run this container. Because so far we haven't been doing anything with running containers because we're just intermediate images, sort of. Well, when the container runs, a script is run called start sh. And in this case, again, we build the image, of course, because if we don't have an image, we don't have anything. And basically, we have created this setup. I started with a JDK. I installed OpenEdge. I created an empty instance, and I created an application with that instance. Now, if you want to run this, this is the command. And there are two parameters, the -p and the -v, which I haven't explained yet, but I'll get to that later. The important takeaway from this one is that I'm actually running the last one I created, the last one I built, and that's the Sport 2000 PES for the version 12.2.6. As soon as I run this, the CMD I just showed you is run, and at the bottom right side, the content is actually is displayed of whatever is in the start shell script. I say, okay, this is the log file. I create it, and then I start tailing it, and it's a bit strange, because what's happening over there is normally a Docker container finishes as soon as it runs, it stops running whatever you set in the CMD file, but it's a shell script. So if the shell script ends, then the Docker container exits, and it doesn't matter if your PES instance is still starting, because it doesn't care, because Docker thinks, well, I started a process, which was my shell script, and I finished it. So in the shell script, you actually have to make you have to do some stuff to make sure that it doesn't end. And in this case, we're just tailing, and tailing is just a Linux command for you who don't use Linux too much. It looks at the contents and just displays the last line, the last line, last line. And you won't see it, you actually do, but this prevents the shell script from preventing. So, and in the meantime, your instance is actually running. Port mappings. You actually can run the same image more than once. So what happens if you have a port, you have an image running on port 8810 and you run it 3 times? Then what? Well, then we have a thing called port mapping, and basically you can map whatever is in the container to whatever is on the host. Remember, you run images or you run containers on a host. So the container port obviously is, in this case, is 8810. But whatever we want to run on the host, well, I don't know. But in this case, we specify a port P 8080, and we say we map that to 8810. So from the outside, I say HTTP blah 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 8080/web, and that is translated into 88.10 in the container, which is explained in the picture on the bottom side. So the outside world sees a different port, and this way you can easily put multiple containers next to each other, because you can easily do a -p 88, 80, 81, 80, 82, and all map those to 8810. A lot of 8s, but what I already said. What happens in the container stays in the container unless you tell otherwise. For production databases, it's not supported. OpenEdge and PES OpenEdge databases are not supported in production, but they are in development or in test environments, which can be quite handy. Yeah, I don't know why. It's probably something to do with support. But you have to ask Progress why they don't support it in production. But now, if you run your database in the container, already said, if your container, shut down your container, everything is gone. And for that we have a thing called volumes, volume mappings. And exactly, because we already saw it. The volumes are used for if I want to expose my log files to the host so I can look at them quite easily. Or I want my database files on my host so I can backup them and I can persist them. So they're no longer running in the container, but on the files are actually stored on your host file. The mechanism for that is called volumes, and we already saw one, which is the /f/license. Now, if I map this volume, which is the internal name, to something which is actually on my host, it's persisted there. So if I tell, and I have that on the next slide. So if I do a -v, see, this is where my host file is on my laptop, or could be on my laptop, and I tell it's located on /f/license. This way, my local file on my laptop is volumed into the container, and so I can use it. And this the way I don't have to bundle license files along with my images. Pretty much the same for the database file. So if I do, if I have a database container which has the database files in /app/db, and I do a volume of app/db, and I map that to a directory on my laptop, you would see the files. And if I shut down the container, the files are still there on my laptop. So this way it's persisted. Patrick?
Is that file read-only?
No.
So you can change it from within the Docker container, and it changes on your laptop?
Yeah, of course, because otherwise it's pretty much useless running a database in a container. But yeah, whatever you do there, but it works both ways. So the databases, you run the database basically in your container and you want to put the files outside, but there's another way. The licenses is pretty much the other way around, because you have something on your host and you want to put it in the container. And look at it, the configuration pretty much works the same. So you make a generic image and you run that image and you inject the configuration which makes it specific for a certain customer. So you can put it, you can change the configuration file on your laptop, and you start it with -v, and you just inject it in your container and then get the specific behavior for that particular customer. Again, setting this environment variable is important, because otherwise Progress doesn't know that it is in /app/license, and it probably end up thinking that it is in user DLC, or should I say /PSC DLC, because Progress decided not to use the standard installation. Anyway, what is important? One container, one process. You want your containers to be as specific as they possibly can, because it's tempting to, if you have an application, it's tempting to say, okay, well, great, I have a container and I put a database in it, and I put a PES instance, and then I have one container and I can ship them everywhere. Yes, but until you want to do something like load balancing. Because you can't load balance 3 containers with the same database running on, with both PES instance and a database on it, because you end up with 3 databases. So if you make the container as specific as possible, so only a PES instance on it, it's way easier to scale your application. And it makes it more easy to take away parts as well, because if you have one image with both your PES instance and your database, and your PES instance starts to ill behave because it's some sort of memory leak, and you want to shut down, yeah, then you shut down your database as well. So, like I said, it's tempting to put a lot in a container at first when you start using with it, but don't do it. You should be really anal about it. One process, one container is one process.
So your container with both the class and the database, you think it's better to separate them?
Yeah, absolutely. No, this implies, of course, that you never have one. Just take a look at the time. You rarely end up with one container, so if you have an application, because there's always a database and a PES instance. So we need something which puts them all together. And putting them all together for various reasons, because we want to specify, maybe we want to run 3 instances because of load balancing or failover, because if you have failover, you have 3 PES instances and one ill behaves, you just take it out and restart it, and then but the other ones were still running, so your application, from a user perspective, your application keeps on running. And not seldomly there is a container which serves your Angular application, for example, as well. So if you look at it, yeah, well, what I use in this presentation, there are various options, but I use Docker Compose as the mechanism for putting all these containers together, because Docker Compose handles the dependencies between the containers. I mean, if you have, for example, again, the PES and the database instance, you want to start the database instance first and then the PES instance, because otherwise your connections fails and not, well, you know the stuff. What also is interesting about Docker Compose, that it takes care of the networking between the containers. So you can only expose what you want to expose to the outside world, and the networking which is going on between the PES instance and the database is just hidden from, so the database container never gets exposed to the outside world, which is, from a security point of view, something which you want. Now, I prepared a little bit of setup just to show you what you can do. Over here at the top we have a load balancer, and when I did this presentation 2 years ago, I used Apache HTTP server for load balancing. But we have some, we're 2 years further, and which is eternity in Docker world, because things are going quite fast. Lately thanks to Thomas, basically, but I'm using a load balancer called Traffic, because Traffic is a little bit more intelligent about and a cloud aware, I would say. But in this case, I want to do a get with this URL, with this host most specifically, and in Traffic I can say, well, if you enter my Traffic instance with this host, then I have to offload it to the PES instances. But I can have multiple rules. So if I, for example, say that the UI part needs to go to somewhere else with a different URL, then I can route to differently. So in this case, there's just one rule which says, whenever you come in with poetsummit.bfv.io, offload it to the PES instances. And the PES instances are connected to the sports database. And oh, that's the wrong way around. I have some time left. So we're hurrying a little bit. Now, I should sit down a little bit, because over here, this is the basic structure, the high-over structure of a Docker Compose YAML file. YAML is for yet another markup language. And as we already saw, we basically have 3 levels. The top level, which is the router, we have the PES instances, and we have the sports database. Those are the services. And well, this is the way they look high over. Now, if we look at the database, we say we want to start with the sports, my glasses, sports 2020 database, again, version 12.2.6. And our volume in the licenses. Well, we already covered that. This is all I need for the database. And I use the database. Sometimes you have the data in the container and not volume it out, because the next time I started fresh. And when you're doing testing, for example, you reset your database, you shut down your container, you restart it, and you end up with the same database you started with, and not with the mess the previous tester left behind. Same thing for the PES stuff. I have an image definition. I use this image. I volume in my license. I can say it depends on the database. This way, okay, I have to start the database first, and I can set some environment variables which are available in the container. If I do an OS getenv in the 4GL, I can get the values I specify here. And the last one is a little bit complicated, but this tells traffic, so my load balancer, that actually whenever I hit something with this host, then you should tell it. You have to configure traffic. I say indirectly to traffic from the PaaS instance level. I say, okay, whenever you see something like this, give it to me. And this is the traffic definition, not overly complicated. And the basic takeaway is here that I map the inside port of traffic, which is 80, to the outside port 80 as well. So, but I just could have said 80 to 80. Now, if we run this, the command is docker compose up. Yeah. Oh. Why is... And this is interesting because I expected it the entirety of my screen to... Sorry? No, I don't think so. Because as soon as I... Okay, this is getting a little bit difficult. Just a second. Yeah, well, that's so much for the demo, because apparently I can show you nothing else but PowerPoint. Yeah, I did. But it was a little bit... Yeah, well, it's insisting on... okay. Now, there's always a little bit of a contingency plan, of course. So. Okay, there we are again. What you would have seen, it's awkward. If we go over there, we enter the URL, which actually turned that. Because I wanted to start it up with 3 instances, that it's just load balancing round robin via all the instances. And basically the takeaway here is that if you look at it from this point over here, this is the entire command I need to run the entire stack. So once I have all my images prepared and I have all the, I have my Docker compose file, there's nothing else needed than just one command to run it up. I have a backup laptop along with me. And I decided I just needed to copy the OneDrive, via OneDrive my presentation. And I copied the Dockerfile via GitHub, because I put all this stuff on GitHub. And I just ran the Dockerfile, and all the images were drawn from Docker Hub, and it worked straight away out of the box with nothing else. And that's the strong part, because if you develop something and you want to test it, you create a Dockerfile and everything is there. You put it on the images on the registry along with your Docker file, your Docker compose file, and then you're now. Okay, almost there. Use cases. We can use this basically, once you start using Docker, you see the use cases popping up everywhere, but you can make your life a lot easier. For example, if you do CI/CD, normally you start up with setting up Jenkins, but you run Jenkins in a container as well. And you can, the thing which actually is building can be a container, and the thing you actually built, so the result of the artifact you're building can be a Docker container as well. So, and you can automatically upload these to whatever registry you're using. As I already mentioned, testing becomes easier as well because the images are the same everywhere. Sorry?
We will be not getting any input.
Okay. So the testing stuff, what I create an image, it runs everywhere. You can use it for development as well, and I would recommend the presentation Thomas Hansen gives along with Mike Leeware tomorrow at 15:15, 3:15. You can use it in production. Thomas and I are going to have a presentation on our first stages of what was needed to turn a Windows application into something which you can run on Docker on Azure. So that's today's presentation on 3:30. I'm pretty much out of time, I suppose. This already covered. Yeah, well, the good thing is, of course, that there's no installation anymore necessary. You could run any progress version on your laptop without ever installing a version. Once you have your images ready, then it's easy. The bad thing about it is creating the image is not always easy. It may seem pretty easy at first, but if you have complicated applications, your Docker files and etc. become quite complicated as well. There's no such thing as shared memory anymore, and that's basically why with the server-side query resolution, because of Docker. Well, that's what I suspect. Database doesn't scale horizontally, so you can scale whatever you want, but the database is still just one database. And there are no Docker files for what programs actually did to make up their own images, so you don't know what's in there. Sometimes you get bitten by that.
Docker history doesn't work.
Sorry?
Docker history doesn't work.
Sorry?
The Docker history, the list of...
Yeah, but you see, but what they did the installation on their own laptop and then copied everything they did into the Docker file, and then you don't know what's happened. And like I said, there are sometimes you come up with some nasty surprises. The ugly thing, the container sizes are big. Normally, we're talking about containers like 100 or 200 megabyte. I haven't seen anything with PES on it with less than 1 gigabyte because the program ones are pretty small, but then you have to add another 400 megabytes because of Java. The OpenEdge database needs a lot of ports. Almost all databases just use one port, but we need to use all the broker ports and the container server ports, so that end up being a lot. And you have a lot to learn. I already said I wanted a 4-hour session, but because once Docker Compose is nice, but it is not an entirely, I wouldn't run production with Docker Compose, and you have to use Kubernetes or something, and then stuff really gets complicated. So you're looking at a big investment up front. It's not something, don't let your boss push you in, I want an application on Docker next month. You probably you're not able to pull it off. It takes a lot of effort and a lot of throwing away and restarting again. It's just, you have to wear on you, I always say. But see for yourself. It is interesting, however. This is a slide, well, you obviously see it. Everything I do, I put on GitHub. So the images are there, the web handlers are there, the compose files are there. I'm a little over time, but are there any questions? Thomas?
OpenEdge and Docker containers on Windows?
Yeah, I already mentioned, that's actually not supported. I mean, basically it's the same story as installing OpenEdge on Windows Core, which is not supported either. So you do have to move your stuff to Linux if you want to run PES. So the containers run on Linux. I mean, you can run, on Windows Server 2019, you can run it on Windows, on a Windows host. 5?
So other than it's not supported, are you aware of issues running Docker on Windows?
I haven't tried it. Yeah, but not you can if you run OpenEdge on Docker, you're running on Linux containers, and you can't run OpenEdge on Windows containers. No matter. Yeah, that's what I said. On Windows Server 2019 it's supported, just as pretty much the same as it is on Windows 10 and Windows 11.
But everybody says it's not supported, but nobody ever told me an actual issue.
You can't actually install Windows OpenEdge for Windows into Windows 10.
No, I don't want to do that. I want to use the Linux-based images and run that on a Windows PC. But it's not supported. Nobody tells me what are actual issues.
Yeah, but you know, it's pretty much the same with it's pretty much the same with the database, I suppose. Database is not supported for production either. I wouldn't see a reason why. But a little bit of a community thing. It's not so much traffic, but we do have an OpenEdge channel on Slack, and I think a community is a good thing. We need to communicate a little bit more with each other, take advantage of all the experiences put out there. Now obviously we have a community, but if you want to move with a little bit less latency with your conversations, use Slack. It's a nice thing. We actually got 100 people right now, but it's not very active, but we could use some new blood. And undoubtedly we have several channels. I don't even know if there's Docker, but we see the PES, we have DBA stuff, we have CI/CD stuff, and all of the usual suspects are there, and sometimes they even answer. Okay, that's my presentation for today. Sorry about, it's a display thing, but for those of you who are actually in here, I can show you whatever I've prepared for a presentation, just to click around and see that it's actually working, because it's pretty easy and it works pretty fast as well. Thank you.
Thank you.